Give the domain of the function below in interval notation. This first function is a rational function. It's best to factor the denominator. In this case we have x minus 10 times x plus 5. So we can see that x should not equal 10, or else we'll divide by 0 in the denominator, 0, and then x is not equal to negative 5. So we're not, let's see, interval notation. So on a number line, at negative 5 we have a hollow dot, and at 10 we have a hollow dot. But everything else is fine in this function, meaning everything else is the domain. The domain is the set of all x values that work. We're only trying to exclude 2 values, so we have 3 intervals from negative infinity to negative 5, soft bracket, then union, then the middle interval, negative 5 to 10, soft brackets, and then union from 10 to infinity. And here we have the interval notation for this first rational function. Don't divide by 0. Notice the numerator has nothing to do with the domain of a rational function. Just the denominator needs to be analyzed. The other option would be set notation, not requested, but it would be the set of all x's such that x is not equal to negative 5 or 10. It's a little bit more convenient notation, but that was not requested. The next function is a radical function. Now with the radical functions, we want square roots of non-negative. We don't want negatives. So the x minus 11 is the only part we need to analyze. This is called the radicand of the radical, the stuff inside. To be non-negative means we are greater than or equal to 0. So the inequality we solve is x minus 11 greater than or equal to 0. That would be x is greater than or equal to 11, and in interval notation that would be hard bracket 11, comma, infinity. Okay. This is the type of analysis done on even indexed radicals, square root, fourth root, sixth root, eighth root. If it's an odd index like cube root or fifth root, the domain is all real numbers because you can have a negative underneath one of those radicals.